So I had a meltdown. Hey guys, it's Andy again. Today I'm in my shop breaking my toys again. Today I broke my knocker. This guy right here, this solenoid used for tamping on my Verneuil Furnace here that makes the synthetic rubies, I had a little meltdown. It's only rated for 12 volts, but I think I was up maybe around 30 volts. So it was, during the experimenting, it was getting too hot, and then the wires started melting down, and my PLA holder melted down also. So it stopped working, so I have to fix this now. My plan is to fix this situation is, so I printed out a new solenoid holder here. It's the same as what was up there before, and I had to get a new solenoid because that one's pretty much toast. The way this works is this slides in here, so you can see like this, screws in here, and then the solenoid activates, pushes down, and what it does is it shakes the entire canister that holds the powder inside, which then makes the powder drop down through the oxyhydrogen flame onto the seed crystal, and that's what creates the ruby. But I'm having trouble. Like I said, this is only rated for 12 volts, but I think I was up to 30 volts. But even though it's intermittent, it's doing this for a long time, about a feed rate like this. It gets quite hot since I'm pushing it beyond what it should be doing. My thought to fix this is I have these two USB fans that actually pump out quite a bit of air. So I was gonna design and 3D print a bracket that holds, it'll be like this, both fans like this, in a carriage that will just slide over this shape here, so I can take it on and off. So it'll be on a carriage like this, and I can slide it down, and this will keep the solenoid cooler, much cooler, when I need to push it up that high. Now, you know, why am I pushing it up that high? Because there's a lot of things going on with this, and I'll show you in a little bit. What I'm trying to do is get the proper feed of the powder dropping down. You don't want too much, you don't want too little, you just want the Goldilocks just right. I'm experimenting by varying the speed at which the solenoid activates, from slow to fast, how hard it's hitting by adjusting the voltage, and then third, by adjusting the screen size that's in the bottom of the canister that allows the powder to sift through as it vibrates and then fall down. So I have those three issues to deal with, and sometimes you can't really, I don't know what's going to happen until you actually get into it, how the powder's going to flow. So that's why sometimes I have to force it and over voltage this at the sake of ruining the solenoid, which, if anything, that's the easiest to fix. Otherwise, I have to keep creating the seed crystals here and then stop the run and redo a new run. But that takes a lot of time, a lot more work of resetting everything up. I'm fine with it's more cost effective just to burn out the solenoids, keep going, experimenting to get it right so I can get some data, and then eventually grab another solenoid like I'm doing now. But I'm pretty confident this fan solution is going to help keep it cool should I need to over voltage these and then push it harder than it's supposed to. So it's a band-aid, but this is all R&D, so that's the way it goes. Let me go over, explain how this furnace actually works. So this is the unit here that you can see. I'll give you the tour of it here. Designed and made everything myself. in my shop here. You can see there's a ball screw motorized table in there. So the way this works, this canister here from this point down to about here holds powdered alumina oxide. You can see in here, it's very pure grade. And inside there's a 3D printed cylinder with a screen at the bottom, and it acts as a sifter. So as this activates, it shakes it and it sifts the powder, so it will drop down through this section here and down through the oxyhydrogen torch. Now this section also has oxygen going into it, and then you can see it'll drop down. So you got the powder and oxygen going down through the center here, and it drops down through the flame and then onto a pedestal with a seed crystal, and then it starts building up the ruby from there. These are ones my early attempts to do, and you can see how they grow on the seed crystal. These are commercial available ones, so these are perfected, and these are done by companies over in China over there. They're very good at it, but I'm getting there. This will be like this down here, and this will be slowly spinning and dropping down as it's building, so it's always in the same spot of the flame. And as the powder drops down through the flame, it melts and it builds up the layers. It's controlled by a touch screen where I can change all the variables of RPMs, how fast it's rotating and dropping down. And that controls the servo motors back here that you can see that control the movement up and down. Right now this is my controller setup that controls the tamper solenoid here. I have it set up here because I'm still experimenting, controlling the speed and the power. But once I get it all set, down in the base here there's a controller box that I'll include it in the original Arduino programming down there, and this will all be removed and also included in down there. So next step is to fix my meltdown here. That didn't smell good, but surprisingly it lasted a long time. I'm here, I 3D printed out a new one, so now I'm going to design the carriage that holds these fans and then put it together and see if it works.